Thank you, Ran. So how many of you here identify yourself as industry as opposed to academia? Can you raise a hand? Okay. And how many of you identify yourself as academia as opposed to industry? I see. So the two quantities don't add up. I wonder what's the rest of the people identify themselves as humans? Okay. Hopefully interested in security. Okay, so basically end-to-end encryption is, we know, very, very effective mechanism, security mechanism. Seems very basic, as Ryan said, kind of classical. But then how come it's not really used? You know, how come it's still not adopted? And the reason is that there's two challenges, two very important challenges and difficult ones, is functionality and usability. So you've heard about so many compromises, countless of them, but really many of them have the same layout in common. There's a server that stores user data, sensitive user data, and an attacker steals it. Okay? So this is a super common scenario that people today just try to protect by building walls around the server. Firewalls, access control, all kinds of different soft or hard walls, in the hope that they will prevent the attacker from breaking in and getting access to the data. But attackers still break in, right? We still have this stream of data breaches that don't seem to stop. And the reason is quite fundamental. Attackers could be hackers, and that's because software is complex and has bugs that can be exploited. And that's not going to change, ever. Cloud employees, so more and more companies are putting their data in the cloud, and you use so many cloud services, and cloud employees have many times, legitimate server access. They have root access to the machines, they need to maintain them. And then there's subpoenas, which literally for a subpoena, you have to give up really the data that exists in a server by law. Okay? So these attackers are going to exist forever, and they're going to be able to break into walls of the server and get access to the data. That's why it's very, very important for us to make end-to-end encryption work, and make it work for all the tools that we use on a daily basis. Why? Well, with end-to-end encryption, only the ends get to see the data. So Alice and Bob here each have an encryption key, and they encrypt the data they put on the server, and only they can decrypt it. So the server can never decrypt the data, and only sees encrypted data. And this is super, super powerful, because you don't have to worry about what gets compromised at the server, whether it's the operating system or your application or your access control, or there's a cloud employee, or you get a subpoena. Who cares? Okay? It's going to be encrypted. So this is a super, super powerful notion that we ought to have today in much more software and systems that we use. Well, actually, there is some good news that WhatsApp actually has end-to-end encryption. Okay, so this is unfortunately the only mass adoption of end-to-end encryption today. You know, WhatsApp turned it on, and automatically, as a result, most of you are using end-to-end encryption for that specific little app. But it's still largely unused for file sharing, document sharing, email, social media, all kinds of other applications that you use. And the reasons are two big challenges. Okay, so people have definitely tried to use end-to-end encryption for email. Like, think of PGP, right? It's an old software already. Use it for file sharing, use it for many other things. There's even other proposals right now and attempts and startups at doing that, and they've been in the industry for a while, yet they just don't get adoption. And the reason are two main challenges. One is the lack of functionality. So if I encrypt the data and put it on the server, then it's kind of garbage, right? So what can the server do with this data? Can send it farther, but can't really do anything too meaningful. How are they going to have a business model? You know, how are they going to recommend things to you if they don't see your data? They're not going to want to run such service, many such cloud providers. Or how are you going to search on your data? I mean, think of search. You use search on so many applications. Imagine life without search. It's kind of hard. Okay, so how are you going to search on encrypted data? So the other problem is usability. There's a lack of usability. So PGP, one of the main reasons people believe it wasn't adopted is because it was hard to use. When I want to talk to someone, I have to figure out which public key to use. I mean, the user having to deal with public keys, and then what if they lose their public key? All of this is a big mess that just scares people away from end-to-end encryption. Okay, so if we want to have end-to-end encryption much more widely adopted, we need to overcome these two challenges. So a lot of my work tries to deal with this. Okay? Both my research at UC Berkeley and my work in my startup. And for functionality, the idea is we're going to try to compute on encrypted data. Okay, if it's encrypted, it's going to be encrypted, so we need to deal with it. We need to be able to compute with the encrypted data. And then I've been working on various mechanisms to make it easier to use, reconcile the tension between usability and functionality, usability and security. So I'll give you a sense of a little bit of each one of these. But we have basically also made this, some of these real in a real product that if you want, you can download and use, Preval, where we basically have encrypted file sharing and encrypted email. It's free to download. It should be very, very, very easy to use. If not, just give me a call and complain. All right, and it should integrate with the usual tools you have, like Outlook, Apple Mail, Gmail. It's just a regular folder for file sharing on your machine, so you just drag and drop files. You don't have to worry about keys. And it works on pretty much all your platforms, Android, iPhone, Windows, and so forth, okay? So let me give you a sense of how we go about addressing issues at each one of these two challenges. So for functionality, there's this really cool paradigm introduced in '78 by Rivest, Adelman, and Ertuzes, which basically says, well, let's compute on the encrypted data. Okay, so the server has encrypted data and needs to, for example, give you some user recommendations to basically make money so they can host this service. Well, one possibility is you're going to, how do you compute on the data? So one possibility is you just send the key to the server just for that specific computation, and then you're going to discard the key once you're done. That's actually a very bad idea because it's not end-to-end encryption, because the decryption happens also in the middle, and the attacker can just get to see the data during the time, or the key. Instead, the idea is to literally compute on the encrypted data without seeing it, obtain an encrypted result, and then the result can be decrypted by the client. So again, the server doesn't ever get a decryption key and doesn't ever decrypt the data. So this sounds like magic. How can we possibly do this? So let me give you one very simple example of how you can do something like a summation. The idea is that the encryption scheme can have some mathematical properties. So this is PIA encryption, which is a homomorphic encryption with respect to addition. It's actually quite fast. It's still used today in a number of applications. It's not fully homomorphic, so it's quite fast for the specific operation of doing an addition. You can take two encryptions, one of X and one of Y. If you multiply them in a certain group, then you get the encryption of the sum of the two by the mathematical properties of the encryption scheme. So now if you have your server that has your encrypted data, the server has no idea what the data is, but you tell the server, add the data up for me, and the server is going to multiply it and get an encryption of the addition, of the sum. Again, the server doesn't even know what the sum is. It doesn't know what any of these values are, but it still does the work for you. Okay? So this gives you intuition into why we can compute on encrypted data. And since then, there's been so much research. A lot of my work has been in this space of doing all kinds of things. So for example, we can do search on encrypted data quite efficiently. We can do SQL queries. You can do user recommendations on encrypted data without seeing the user data. Machine learning these days, getting a very hot topic. Okay, so you can basically do a lot of functionalities. So the idea is that end-to-end encryption could move to applications that require richer functionalities. All right, so let me give you a sense of the other challenge, and that is usability. There's a big tension here between usability and security. For example, especially when it comes to dealing with keys, key recovery and key distribution. So let me just focus on key recovery as an example. So let's say that Alice uses end-to-end encryption. She stores her encrypted files at the server. She has the key. What if she loses the key? Well, if you lose your key with PGP, you lost your data. Many people are not going to use this, or companies not going to use this if that's a possibility, losing the data. So many solutions today for end-to-end encryption, what they do instead is they back up the key at the server. Well, again, that is not end-to-end encryption, okay? Because the attacker can just steal the key. You just compromised your guarantee when you do that. And that happens a lot actually right now. What we try to do is to reconcile the two. Okay? We don't want to give the key to the server because we don't want to compromise end-to-end encryption. But also, we can't just keep it at the client because then if the client loses it, lost their data. Okay, so how can we have both things? So one notion that we implement in Preval is something called approval groups. The idea is that you take your key, this happens automatically, but your key is split into pieces and is given to different people. In a company, this is easier. It can be a piece goes to your boss, then to some IT administrators. And then any one of these people, they can't see your data because the piece doesn't hold any information about your key. Okay. But if you can put together multiple pieces, then you can reconstruct the actual key. Okay, so you can, if you lost your laptop and your key, then your boss and the IT administrator and someone else, together they can reconstruct your key. But alone they cannot. So in this case, Alice's approval group can be 2 out of 3 people, either her boss, admin, or admin 1 or admin 2, but it has to be at least 2 of them. Okay, and this can be implemented mathematically with something called Shamir secret sharing. It's a very, very cool primitive. How many of you are familiar with Shamir secret sharing? Okay, a few. Okay, for the people who don't know, it's actually very nice and clean technique. The idea is that your key, you can put your key on the y-axis, and for if you're interested in 2 pieces out of 3, then what you do is you draw a random line through it, and you give a point on it to each one of your approvers. Note that 2 approvers can reconstruct the line, which means that they can reconstruct the intersection with the y-axis, which is your key. But any one given approver can reconstruct the line because there can be an infinite number of lines going through that point. Okay, so that's really cool. And in Preval, basically, because we want to, we're working with a lot of organizations, so we want to actually mimic their internal structure. You can have arbitrary and and or trees. So for example, you can say that, to reconstruct Alice's key, you need Alice's boss and admin 1 to come together, both of them, or 3 out of 4 people from separate departments. Okay, so and companies express all kinds of policies that they have in this way and is enforced using Shamir secret sharing. Okay, but the point is that with this mechanism, if you lose your key, other people are going to be able to help you reconstruct it. At the same time, it's not the server that backs up your key, hence you still have end-to-end encryption. All right, so to conclude, I hope I convinced you that end-to-end encryption is a very, very effective security mechanism that can conceptually change the kind of guarantees and the kind of attacks people can mount on systems today. There are challenges why tools today haven't gone to file sharing or email, okay, and those are functionality and usability. However, there's a bunch of research that shows that, okay, we can do computation on encrypted data, so the functionality issue for a broad class of applications can be addressed. And And for example, one such example is, I worked on Preval and still working on Preval, is one example where we try to capture some of these research techniques and make them super easy to use and a product that is free to download and try out. And thank you.